Today we will gonna test lab 12, which is buckling of the column. Okay, let's see the lab direction. So if you see it, we have buckling of column like this, and test, which is just increase the load like this, and our support is assumed to pin because the slenderness ratio is equal to 1. It's easier to calculate. What we have to do is just use this the hello. Okay, so we have the specimen like this. We have 3 or 4 column, steel column. Assume that this is a steel column with different length. Is referred to the different slenderness ratio. Okay, and just find the sigma critical, which is from P critical, which we test in the UTM, and compare to this equation. Oh, sorry. Here, this equation, which is the Euler sigma critical from Euler, which is pi power 2 multiplied by E divided by slenderness ratio power 2. I think you understand in Ajahn Siddhichai class already. So, but normally the real sigma critical will more than the Euler critical. Normally, you will see when you get the raw data and just compare and make a discussion. Okay, so the machine we use is this UTM, kilonewton. Okay, so you have any question about the lab direction? So we have 3 specimens, which is the shortest and middle and the longest specimen. What you have to do is just use the vernier, measure the width 3 times, just random check. Okay. Oh, sorry, this is the thickness. The width upper, middle, and the lower, and average it, and find the thickness for 3 times also. Okay, so if you already measure the thickness and the width of all of your specimen,
Why we measure the thickness and the width? Anybody? Why you measure the thickness and width?
Student answer.
Yeah, it's okay. Go ahead.
Okay, so
We don't have much time on this.
let's move to the UTM.
ผู้ฟังใครอ่ะเรียนกลางเลย
ของผมครับ
ระวัง
วัดตัวอย่างจดข้อมูลจริงๆจังนะครับคุณต่อมานะ
Okay, here is the UTM which we use.
วัดจดข้อมูลจริงๆจังนะครับย้ำนะข้อมูลจริงๆนะตัวไหนตัวตั้งเลย
ตัวยาว At first, you have to move the red needle to the 0. And how to install is just put the specimen in the slot here. And just
ไม่ได้ติดกระดานทั้งสามมากเลย
May I help you? Actually, do it by yourself is better. You will know when it's going to put in position or not. It's okay. It's okay. Go ahead. Just move it a little bit to adjust it. Okay. You may start now.
And here now we have to measure the length. Maybe okay, in this case is 111.58. Okay, so what we have to do is just increase the load until you get the P critical. See, both of them is moved together. Okay, more.
Not yet.
โอ้ตกใจแล้วมันหายยัง
It's just some hiccup.
Okay. And when we know that is already the P critical student.
You may move a little bit so you can take both of them at the same time. Take this one also. So they will see the marking. Can you take move? Okay, move your hand. It's okay. It's good enough. Oh, see, it's buckle already. It's kind of immediate failure.
It's not follow the theory, right?
It's okay. That's why it's stability failure.
Okay, so here you see the red needle is just point out the critical
What value of it? So do we what?
is around 9.7,
Okay,
9.8.
Let me show you guys something. See, steel has some permanent deformation already. When you release the force, some of the deformation will return due to the elastic recovery. And then this is not really the total failure. Why? If you increase the load again, you may see the columns will be able to take some loads. And when you increase this by continuously do so, you see, it will not reach the previous point, but it's not totally collapse. It still can take some load on this. So the note on this may be technical in some aspect, but anyway, in the reality, this column, if it is in a factory or in the industrial building, we are supposed to replace it with a good one, good and larger one, because it's buckled already. But in reality, I just show you guys, it still can take some load on this. So after that, make it and one be no forget. After you take off. Okay, next.
You see, it's like a permanent deformation like this, and you have to sketch this specimen how it's gonna be after we test. See, for international students, I will post the raw data for your group. Don't confuse about your group number. Please Look at only your group data. Okay, any question?
Do we have quiz?
No,
Okay,
we have
thank you.
not. Okay, any question?
Hey, what is included in the testing result? Like, what should be included? Like graph, drawing.
Oh, yes. Yes. Okay, so what you have to do is just complete this table, which is we have the critical stress from the machine, moment of inertia from the area of the specimen, radius of gyration is from the moment of inertia divided by A, right? And slenderness ratio is L over R, when R is the radius of gyration. And then you have to calculate the Euler stress by this equation compared to the critical stress from the machine. Oh, sorry, it's here. And just find the error from the reality and the Euler stress in the theory. How different? And then you have to draw this graph like in our lab direction. Something like this. We have 4 specimens. That means we have 4 specimens here. Around here. No, here, because in over this part is the short column. What we test is the long column. It will be here. Draw the curve like this. So Ajahn Siddhichai told me that he already teach you in the lecture class, right? Okay, again, what you have to do is just use the raw data, find the sigma critical from the UTM or the reality, compared to what you calculate from the Euler equation, and just compare sigma critical from both of them. How different, how much percent error you get. Okay, and just draw the graph. Okay, I think that's all for our class.